name is Glikson, and I'm here with Ezra Silvera. We will be presenting the next session. We are from IBM Haifa. The topic is management of heterogeneous cloud infrastructure. And in particular, we're going to focus on a specific example of heterogeneity, which is managing virtualized and bare metal workloads on OpenStack-based cloud. And this is based on the presentation we gave at Atlanta, so sorry for those who might have heard already some of the material here. The presentation is, we have two parts. The first one is kind of general motivation and some overview of heterogeneity in the cloud and some trends. And then in the second part, Ezra will elaborate on the specific case of bare metal and virtualized workloads. Okay, so let's start with some background and motivation. So looking at the usage patterns in the cloud, if we look at the early days, which is the left-hand side column here, so the motivation for moving to the cloud is obvious, and it also didn't change much. It's all about agility, efficiency, self-service, elasticity, and so on. So when the cloud started, most of the applications were rather, well, I wouldn't say simple, but there are a few kinds of applications running in the cloud, mostly around the dev and test, and there are also some native web applications. And in order to meet the needs of those applications, the hardware that were offered as a service in the cloud was rather standardized. As an example, in the Amazon Web Services, there was just one instance type in 2006, which probably was enough for many things. Now looking at the trend of the cloud adoption, we can see that there are more and more types of workloads that are migrating to the cloud, or which basically includes also some what so-called non-cloud native applications, some legacy applications, business applications, including HPC, analytics, big data, and so on. And all of those applications, or the providers and the users of those applications, want to leverage the benefits of the cloud. So there is a demand from the provider perspective to offer more configurations and to more flexibility in terms of the underlying infrastructure. So looking once again at the Amazon infrastructure as an example, at the moment there are more than 60 different instance types, depending on how exactly you count them, but that's pretty much the order. And we can also see an interesting trend of offering bare metal servers in the same cloud model as we used to with VMs. So you can go into a portal or through an API and get a bunch of bare metal dedicated servers from SoftLayer, InterNAP, or others. So, and this is also one of the reasons for this is the desire to have more flexibility in terms of the underlying infrastructure and more control. So a few words regarding the heterogeneity. So you can see here some examples at the different layers or different types of resources. You can have different mixes of different resources within the same server. You could have different kinds of compute resources, including GPUs, accelerators, storage. Once again, for some applications, you might want SSDs. For some others, you might want SAN and so on, networking. And also in terms of the virtualization capabilities, this could go from bare metal through KVM, containers, and so on. And all those technologies, they exist today in the data center, and there is a desire or a requirement to have similar capabilities in the cloud for workloads which cannot be easily migrated to a commodity infrastructure. So just a small example to illustrate this. You could have, this is not a real application, but you might think of such an application easily. You could have a web tier, some 3D rendering tier. We're talking about 3D design application. So you might need a 3D rendering tier, databases tier, and a Hadoop tier for some analytics. So potentially you might want to map the different servers to different capabilities for each of the resource types. So once again, so our claim here is that once we move to more and more complex applications, there is more and more need for underlying heterogeneity from the provider perspective. So in terms of opportunities, so there is the application provider perspective and the infrastructure provider perspective. From application perspective, this is all about agility, coming to new areas and new application types. And from the provider perspective, this is an opportunity for differentiation. So if you know how to manage efficiently different kinds of resources, you can offer more flexible infrastructure or to build infrastructure more suitable for certain classes of workloads. A few words about challenges. So first of all, as I mentioned, once you have all this variety of different technologies and resource types, there is a need to manage them in a holistic manner and to offer the users a seamless way to use those resources and to specify the requirements, and I'll touch on that in a moment. Also, the multi-tenancy, which is standard in a cloud or in a virtualized cloud, there are some challenges to provide same level of multi-tenancy in a heterogeneous environment across both in compute and network and so on. Also from the application perspective, once you have this large variety of possible options, it might make sense to have a higher level abstraction to define the requirements from the application perspective that then would be mapped automatically or by some kind of logic to the underlying infrastructure. Also, for the same reason, there are some new challenges related to efficient resource placement and scheduling. And also, for the same purpose of efficiency, the provider might want to do some smart rebalancing between resources between compatible pools of resources to do some higher level optimization across the entire infrastructure, which is something that is much less of an issue when you have a more homogeneous environment. So what happens in this space from the OpenStack perspective? So we can see a similar trend. The basic offerings are designed to provide relatively small relatively small amount of flavors, relatively simplistic approach to scheduling and so on. There are various efforts to expand this in multiple directions, both in terms of hosting of specific classes of workloads like Hadoop or databases, bare metal workloads. There are some efforts to enhance the scheduling. and so on. And the basic claim and the basic conclusion that we reached based on our experimentation is that so on one hand, OpenStack is a good basis to build such an infrastructure, but on the other hand, there are some gaps in the different places. And Ezra will elaborate a bit on the example of bare metal and virtualized and focusing on some of those gaps.
Okay, so I'll try to go as fast as I can so you will be able to get some coffee. So I'll talk about the special case of bare metal and virtualized environments. So first of all, a couple of definitions to make sure we're all on the same page, because everyone talk about hybrid, it means completely different things. So in our case, in this presentation, when I say hybrid, I mean a mixed environment, a single cloud where you have both virtual and bare metal resources, and you can deploy bare metal workloads and virtual workloads to the same cloud. And hybrid application is kind of a composite application, like Alex showed an example where you can put, for example, one tier on bare metal and one tier on virtual environment. We had very simple goals to make sure we minimize the administrator efforts and to have a even for the user perspective, to simplify the ongoing management. And design guideline we set to ourselves was, if possible, to make it happen with an OpenStack-based solution, only without any external orchestrator or anything like that. So this is just an example of the problem we deal with. We have two tenants. Each of them has both physical and virtual servers. Virtual, of course, can reside on the same server, and there are a lot of challenges to that. I want to go quickly, I will not go through the details, just on a couple of scenarios that illustrate the advantages of such environment. So first of all, repurposing of a server. We have two different pools, one that you can deploy bare metal workloads and one virtual workload, and we want to be able to repurpose them, meaning that taking a server on which you have hypervisor and convert it to be a bare metal server on which you can deploy bare metal workloads. The steps are quite simple. We need to detect it and then identify a candidate host to deploy, and then finally evacuate all the VMs, and then we can repurpose it. Once again, because it's on the same, on a single cloud. The other scenario is what we call a dynamic deployment, in which we want to decide whether it will be a bare metal deployment or virtual deployment during deployment. So for example, you want to deploy a database, you do not specify whether it should be a bare metal or virtualized, and we will do that automatically through the deployment, taking advantage of information coming from the scheduler, from heat, and so on. So those are the possible scenarios. There are several approaches if we want to take. One of them is share nothing. You take two different cloud managers, you have separate clouds, and you can manage it like that. And there is the shared everything, where we use a single cloud manager to manage everything together. You can think of some intermediate solution, for example, cells and regions can be considered something like that. Now, we know that OpenStack can manage virtual servers, obviously. We know that OpenStack can manage bare metal servers, for example, Ironic and OOO and so on. So why not use a single OpenStack to manage both of them simultaneously? So this is exactly what we were focusing on, and we called it integrated management. I won't go through I'm being signed, so I won't go through the advantages. They are mapped to the requirements. It's very easy to manage it, simplify administration, and so on. There are a lot of technical challenges. I got lucky to be after Asaf, who mentioned how the capabilities of Neutron. So you just need to multiple that now, because now we need to have both bare metal and virtual, be able to isolate between them, although a single tenant can span both virtual and physical. There are issues of the bare metal itself. A tenant that can deploy a bare metal workload can go and reflash the EEPROM of the NIC and then do any kind of damage you want. So there are a lot of issues there. There are many changes that need to be done in Nova, in the policy, in the scheduler. We now manage everything from a single point of view, so we need to have some kind of hierarchical relation because someone can go and delete the underlying server and we will end up with inconsistency on the VM level. Let me just jump directly to something we tried. So what we tried, and this is actually similar to a slide that Nati showed about the WordPress. We deployed a WordPress application, but this time we wanted to have the WordPress and the Apache goes to a virtual machine, but the MySQL go to a physical server. We succeed to do that with a single hit template, managing everything together. We had to, of course, the details, we had to use some different aggregates for the scheduling. We built the special images for that. You can see down the hit stack resources and the topology that comes out of that. This is a kind of a very high-level architecture diagram of the solution. You can see that, for example, we had to have a special dedicated bare metal management network because even during very short time of the PXC boot and so on, we don't want the user to take advantage of that and take over our management and so on. So it's very delicate details. And lastly, here we have snapshot of the actual horizon. You can see a couple of, I would say, glitches of the current horizon, current infrastructure when you try to manage everything together. So here, for example, you see our bare metal servers. As you can see, they are under the hypervisor view, which is not the best thing to do. And also, on the user perspective, the user can see all the images that he may use, but also a couple of images that he didn't even define. Those are the images that are being used during the ironic PXC deployment. So unfortunately, today in OpenStack, a user can see every image that he can use. Now, here he must use those images, but those are, need to be implicit to him, so this needs to be changed. So due to the short time, let's jump to the summary. So heterogeneous cloud environments are very important. We believe that they are critical in order to host broad spectrum of application. We already see that there are customers who are not willing to move to cloud or virtual environment because there are some kind of a very important piece that they want to reside on a physical server. OpenStack is a promising solution for hybrid cloud, and by using integrated management, as we give example here, we will be able to have a simple, purely native OpenStack solution. For example, the scenarios I just mentioned, repurposing and all of that, we can do that simply by hit. No need for some kind of an overall orchestrator above that. And lastly, we need to have a very careful design to ensure that all our requirements still there, because, for example, the networking issue is very problematic when we come to both virtual and bare metal servers together. And there are still some gaps to be addressed in OpenStack. I did it as fast as I can. If there are any questions, either now or later on, you can ask me or Alex, whatever. Yeah, any questions? Okay.